Hello and welcome to this Simpleware webinar showcasing the Simpleware-CCNY Head Model, a powerful resource for design and simulation. Hope you've all joined the audio okay. I will get started just now. So today's webinar will start with a short presentation, followed by a demonstration, more of a showcase of the model itself. And then finally, if there are any questions from those joining me live today, a Q&A session towards the end. Other than the Q&A, this is not an interactive session today, so attendees will be muted throughout the webinar. The recording will also be available for download once the webinar is over. For the Q&A session, you should see a questions box in your window where you can submit questions at any time, and I will use these and try to get through as many as I can in the Q&A session towards the end. If we don't get to your question, you will receive an answer via email instead. Any problems, please report these in the Q&A box as well. So what are we focusing on in today's webinar? Firstly, I'll introduce who we are and the solutions that we provide. Then we'll focus on one particular solution that we offer, the Simpleware human body models, and what these can help you to achieve. We'll then look at making use of head models in particular for advanced product design strategies and explore the advantages of the Simpleware-CCNY model for these tasks. And then finally, we'll look at this model in a bit more detail, a bit more interactively within the Simpleware software product. So firstly, who are we? We are Synopsys, a large international technology organization leading the electronic automation, design automation field. With a very impressive portfolio of products in this area, but our products and services extend into other fields as well. So more specifically, we are the Simpleware product group. We are developers of high-end 3D image processing software, primarily for the life sciences field, but also materials and manufacturing as well. Our software is supported by a very strong engineering team, and we have a global reach in our delivery of these solutions. So what solutions do we actually offer? These can be split into three main branches. So we have our flagship product, the Simpleware software itself, which is an easy to use GUI-based software solution for processing 3D image data and building computer models from that data for visualization, measurement and analysis, and also export for various applications such as 3D printing, CAD design work, and even computational simulations as well that are actually based on reality. In addition to this, we also offer services. So this can be in the form of software customization and expansion of the software through development of bespoke plugins and scripts, or it can be simply in data processing. If you don't want to purchase the software and process your data yourself, we can do it for you as a service. And then finally, the solution of discussion for today, the Simpleware human body models. So these arise as from a need to design better products. So whenever a product interacts or integrates with the human body in some way, there is value in considering this interaction in more detail at the product design stage. So the technology available of having an accurate and detailed model of the human anatomy that your product relates to, and you can analyze and optimize product performance against that is something that's yet to be greatly taken advantage of. And the Simpleware human body model solution offers a provision for either off-the-shelf or highly bespoke application-specific models for 3D printing, CAD design work, and computer simulation work. Really, this last one, the computer simulation work, is the key strength of the Simpleware models, and also the area with highest potential for improving the product design life cycle. Our data sets consist of an extensive collection of MRI and CT scans covering a wide population range. The models can include outstanding levels of detail and anatomical accuracy, which is configurable to meet the requirements of your application. We can also seamlessly integrate product models from CAD that you may have designed into the anatomical models for analysis of the interactions between those two. So the products that you're working on and the human body itself, that interaction between the two can be very successfully modeled with Simpleware human body models. Finally, if we don't have what you need in our data library, we do also have a number of collaborators and sources for new scans for even more application or region-specific models, where we can really look at the problems you're facing and how to solve those on a very bespoke level. So looking now at the head specifically and the main model that we're going to be discussing today, what are the applications for detailed anatomical models of the human head? Mostly we're talking about computational modeling studies here, and these can be in a number of different areas. So we have electromagnetic modeling for any products that emit some form of radiation near or within the body. It could be something like mobile phones from a consumer products point of view, or some kind of medical treatment device in the medical field as well. Also thermal for any heating products or products where there are risks of tissue heating, like from radiation again. Acoustic, so relating to hearing aid development, for example, or anything where sound waves propagate through the human body. Mechanical, so things like impact analysis, such as for safety gear optimization, and even as far as using computational fluid dynamics, wherever there are flows relating to the product function, such as in drug dispersal, among others. So studies like these can inform both the development of medical devices as well as consumer products. There are a couple of papers here showing some of the previous uses of the specific data set that we're going to be looking at today, mainly in the field of transcranial direct current stimulation, which happened to be the research interest of the source of the data itself. But other than those, there's obviously a broad range of applications for these kind of detailed anatomical head models. So the Simpleware-CCNY head, called that because it was formed from data collected by the Simpleware collaborator at the City College of New York, specifically Maren Bixen. And here they performed MRI scans of a human head with T1 and T2 weighting using a 3 Tesla MRI scanner, which produced scans at cubic 1 millimeter resolution. This data was then taken into Simpleware and segmented quite extensively to produce at the current stage around about 50 anatomies, although there is certainly room for more there. And this includes many structures of the eyes and the brain, but yes, there is certainly potential to add more to the model as well. So this next slide shows off the extent of the segmentation that's currently included in the model. So there's increasingly hidden anatomies in this slide, so that you can see some of the deeper layers in there. You can see we have layers for skin and fat, then muscle and bone, and then as you go further in, you can start to see the structures of the brain and eyes in there as well, and even vasculature, teeth, the tongue, various other anatomies are included. So as with all Simpleware human body models, the format of delivery of this model is extremely flexible. So there's typically a very streamlined method that you can make use of the model in your advanced design workflows. So whatever simulation package or CAD package you're using in your product design development, there tends to be a pretty nice method to make use of the exported model directly in that workflow. So you can either receive a bespoke one-off model, which we can deliver and set up as you require for your specific application. So this can be in the form of a simulation-ready finite element volume mesh with formats suitable for the simulation package you're using, whether it be Abacus, ANSYS, COMSOL, etc. Our generation of these models is also extremely robust and produces exceedingly high quality meshes. In addition to volume meshes, we do also offer NURBS exports for simpler versions of the models, which are very CAD friendly, and so can be used for direct design work in a CAD environment as well. We can also offer triangulated surfaces like STLs and IGES models, which are ideal for things like 3D printing, and also can be useful in some more niche analysis software, such as Altair FICO for electromagnetic simulation, and even our own Synopsys Light Tools product for optical simulations as well. Alternatively, you can purchase the model alongside the Simpleware software product, and this offers kind of the most flexibility in the way that the model is delivered. It means that you have the means to customize your own model and produce as many export variations as you need. We can obviously set up the model within the project file for you so that it's kind of push button ready. You simply select what your desired output is going to be and then run the mesh generation, and it will be ready for you to export. The robustness of our exports in Simpleware is certainly a strength with this and offers this flexibility. So with the exported models, we also have the capability to integrate your device or your product into the anatomical models for simulations where the interaction of these needs to be considered. So with Simpleware software, we can position these CAD models as per your requirements and robustly mesh them alongside the anatomy for simulation. So with access to the software and choosing to purchase the project file version of the model, you can benefit from the most flexibility in this case, since you can start positioning your own devices and exporting models with unlimited variations of those positions and the different product versions you may have as well. So there are other anatomical head models on the market. So what are some of the advantages of the Simpleware-CCNY Head Model over these? As I've already said, we offer direct exports to most simulation packages, meaning there is no need to mesh or prepare or reformat the model before use, like there is with a lot of the other models on the market, where perhaps you're given a very rough STL version of the model and you've got to try and find some way to make it simulation ready. The exports we deliver are extremely high quality, meaning you don't need to fix or remesh the model to make use of it. As long as you're able to communicate your requirements to us directly, the models we deliver should be ready for use in your application. The flexibility that the model affords is also very strong, so you can choose the anatomies that you need, choose the export format that best suits you. You can give us your requirements on model size and mesh densities in various anatomies that you've chosen to include, and to make sure that you're getting exactly what you need from us. And also, since the model was developed in Simpleware software, we do have the option to modify or extend the model as per your needs. So if there's a specific anatomy that's of importance to you that doesn't appear in our current model, we can look into adding it for your version and customizing it for you. So given that, let's take a bit of a look at the model in Simpleware software itself. So I'll just switch over to the project file here. So hopefully you can see that. If you're familiar with the Simpleware software product, you're probably familiar with what we're looking at right now. Otherwise, for those who aren't familiar, we can currently see the scan that we've got imported into the software here. Down here on the left-hand side, we have our dataset browser in the software, which summarizes all the objects that we have stored in this particular project. So you can see under background images, I have my T1 weighted and T2 weighted scans, and I can toggle between those to change which one I'm looking at in my different views here. So the benefit of having these two scans is that you get different contrast in different anatomies of the head. So if I zoom in on the brain, for example, here, we can see with the T1 weighted scan, we get some nice contrast between the grey and white matter. The CSF, on the other hand, is not so visible. If we look at it in here, for example, it's not so visible there. It just shows up quite dark. If we switch to the T2 weighted, we get less contrast between the grey and white matter, but the cerebrospinal fluid shows up nice and bright and makes it easy to capture that. So having the two different scan types, different weightings of the MRI there really helps us to draw out the most anatomies from these scans. And these scans are registered together. They're of the same subject, so we can use them side by side when we've built our model. And that's exactly what we've done here. So at the moment, we have no model shown, but if I scroll down in my dataset browser here, I can see I've got a very long list of masks, as we call them in Simpleware. These are regions of interest that have been segmented and identified within the scan itself. So if I go right to the bottom here, you can see we have a skin mask, for example, two versions, one with the eyes open and one with them closed. So if I have a look at one, I can see this skin mask. It fills the entire image volume here. In Simpleware, we have a very useful priority system. So the order of masks in this list here determines what happens when there is overlap between that, and we can use this to our advantage to make the models extremely flexible. So if, for example, I zoom in and I toggle the fat mask on top of that, I can see I've now got a layer of skin on the outside, and then that fat mask starts a few pixels inside of that skin. So now I've got two masks, one on top of the other. And if I was to generate a mesh of these two masks, the fat would take priority since it's higher up in the list, and I'd end up with a nice thin skin layer surrounding my fat. And we use this to our advantage to make the models extremely flexible, because what we can actually start to do is nest those various structures inside of one another. And it means that if we don't want to include a particular anatomy, so if I toggle on all of these, for example, to have a look at, you can see I've got skin, fat, some muscle structures, my bone, the teeth, intervertebral discs, and a tongue here. So let's say in my application, I'm not so interested in the tongue. It doesn't really apply to the work that I'm doing. I can choose to ignore it from my model. By ignoring it, it doesn't leave a hole in my segmentation, in my model. The tongue just becomes part of the fat, the surrounding mask that it was overlapping. And by doing this, it means we can very flexibly choose which anatomies we want to include in our model and include in our export, and which we can ignore. So even though there are 50 plus anatomical structures included in this model, if I toggle them all on, just so that we can see, I'll just go up to here, and then get rid of a couple of duplicates here, simplified versions. So even though we have this very large number of structures here captured in this model, we don't have to include all of them in every single export. We can pick and choose what's useful for us, what we need, and ignore the rest of them. Also in Simpleware, we have the option to perform Booleans. So if you want to combine certain regions together, for example, in this particular model, we have lots of different structures for the brain. The original use of the model was based around brain stimulation, so it was very necessary or useful to have all these different structures isolated from one another, so that we could look at the impact of that stimulation on those different structures. But maybe in your case, you just need one representation of the brain as a whole. We can take all of these masks and with a simple Boolean operation, combine them all together, and then you just have one mask representing all of those brain structures, and it will greatly simplify the model and allow you to represent it with a much simpler mesh if you're going to simulation, and things like that. So you can start to make the model much more efficient for the purposes that you need. So what we can do, we just go down here to the model section, and I can right click and say I want to create a new model. So I have a few different options for the type of model I can create here. I can choose a surface model. So if I want to create an STL, for example, I could do that with this option. If I want to create a volume mesh for use in a simulation package, I can do that with the FE model option. Likewise for CFD and NURBS for going to CAD. If for now I create a new FE model, then I get that new model here, model 2, and I can simply click and drag any models, any masks, any structures that I want from my masks list and add them into that model. So I can just click and drag a mask, add it in, and build up my model, customize it for my needs that way. So I've got a model here, model 1, which is fairly simple. And I can go in and configure that exactly how I need. So if I open up the model here, I can choose, again, my model type. I've already chosen an FE model, but if I decide I'll change my mind, I can go back and change it. I can also choose the export type. So this is the list of simulation-ready formats that we have for various different simulation packages here. And I can start to specify exactly how I want my mesh to be generated for this. So in the volume meshing tab here, I can choose my meshing type and start to determine exactly what my element edge lengths are going to be like, how coarse do I want it in different regions. I can set that on a per part basis. So if there are anatomies that I'm particularly interested in knowing what's going on with, I can mesh those finer, while in some areas I can obviously leave the mesh more coarse. Likewise with this model, I can do local mesh refinement. So if there's a product that interacts with the human eye, for example, you might want to mesh all the anatomies around one particular eye more finely, and then have coarser mesh settings, more relaxed meshing for the remainder of the regions. We also have the option to just export or model a particular sub-volume of this. If you don't need the entire head for your applications, we can simply crop it down to a smaller region which you need for your application, and we can export a mesh or a model just for that as well. Also to mention, I mentioned it in the slides as well, the Simpleware CAD module allows us to bring in data from CAD. So I showed in my slide the example of the VR headset. We can bring in data like that, import it, and then use the various positioning tools here to integrate that with the model as required. We have landmark-based registration, as well as more manual approaches to positioning these things. And then, just as with adding the masks to the model, we can click and drag surfaces as listed here into that model as well, and mesh those just as easily alongside the anatomical part of the model. So lastly, I'll just delete this model and quickly generate a model that I have pre-prepared. So in this case, this mesh has already been generated, it's stored within my project. So I'll just quickly get it pulled up here so that we can have a look at that mesh in 3D. So this is just a model which includes all 50 anatomies that are included in the head, and it uses Simpleware's default meshing properties, meshing parameters. So this model is kind of like the base, I suppose, the foundation, and then you can do what you like in terms of customization of the model. So we can see that model there. I can also hide the edges there so we can see it and move it around a bit more easily. Likewise, we can clip through the model so you can see the internal elements there as well. It would just take a few moments here because it is a fairly large model. So yeah, we can see those internal elements with the edges on and off there. And with the Simpleware meshing, the interfaces that we have between these parts in the segmentation are preserved perfectly in the mesh. So there's never any gaps or mismatches of the meshing in these regions at these interfaces. We always have perfectly conforming surfaces between those different anatomies, and also coincident nodes along those interfaces as well. So I can just turn that off. And then I can also hide some anatomies to have a bit more of a look inside the model. So I hide the skin there, hiding the fat layer and the muscle. And then we can start to see some of the underlying anatomies that we have segmented here. If I get rid of the CSF, then we get down to the brain, get rid of some of these muscles as well. And we can see that brain meshed in there. So you can see the surfaces that are generated with ScanIP are extremely smooth and tidy. So there's really no work to be done in tidying up the model. The quality of the meshing is extremely high, and that's really one of the strengths of using Simpleware for these human body models. So to return to my slides very quickly then, to end off the webinar today. In terms of contacting us to inquire, if you're interested in the Simpleware-CCNY Head Model solution or any other human body model generation services from Simpleware, you can contact us either via our website, so the synopsys.com website. We have a link to it here, Simpleware Contact Sales, or via email at our standard simpleware@synopsys.com. our sales team will then be able to pick that up, and we'll have a discussion with you about your applications for that, and what kind of models you would likely need. So just to end off then with a very short Q&A. There aren't too many questions coming through. So it's one question we have here. What levels of detail are there in the ears? Are there layers in the ear? And is ear canal geometry included? So yes, ear canal geometry is included. Currently in the ear, we don't have cartilage included in this model. We do have other models which have much more advanced a detail in the ear region, and we are always acquiring more data for those areas as well. In terms of this model, it would be possible for us to include the cartilage in there probably. So it really depends on what level of detail you expect to have in that model. So things like the vasculature and things like that, we're not going to be able to achieve with this resolution of MRI, but cartilage could certainly be included. Okay, just having a look at the questions here. So how representative is the subject? Do we know the percentile in terms of head measurements? Yes, so we have all of that information. If you contact us regarding the head, it's something we'd be able to give you. Unfortunately, I can't disclose the specifics of the head right at this minute. I don't have that information available, but we certainly do know all the details of the subject that was scanned, so we can tell you exactly where they fit in terms of the population. What details do you have in the teeth and soft tissue in the oral cavity? So at the moment, not too much. The teeth are individually modeled, but they are just solid, a single layer. We would have the option to include the I suppose the cavities within the teeth, and some different layers of perhaps the enamel and things like that from this scan. Going much deeper than that, we probably struggle with the resolution of the scan to see those anatomies. Again, if you're particularly interested in teeth and the oral cavity, we do have other scans which focus on those areas more, and we can use those to generate maybe a more specific model for your uses. Are the vessels included in the model? Yes, the vessels are included. The extent of those vessels at the moment is just kind of on, I think if I go back to this slide, we just have the temporal and occipital vasculature currently, but there is again potential to add in more vasculature. There is more visible in the model than we've currently got segmented. So if that's a requirement for you, we could certainly look at adding that in to your version of the model. In terms of how expensive the model is, it really depends on your need of the model in terms of the number of anatomies, and also the exports that you need, if you just need one version, and how much work is involved in customizing the model for you, then it's really something you'd have to contact us about. Let us know what your specific requirements are, because the prices can vary quite significantly depending on exactly what you need. Can we have the recording of this session? Yes, the recording of the session will be available at the end of the webinar, so we will give you the opportunity to go and download that afterwards. Okay, so I think that's about all we have time for the Q&A session today. But if you do have any questions that are unanswered, we'll certainly get back to you via email with specific answers to those. Okay, and I will wrap up the webinar session for today. So thank you everyone for joining me. I will now stop the webinar.